Today we'll start current electricity. And in current electricity, we'll be doing first definition of electric current, then some important features of the electric current, and after that we'll do the expression for electric current in terms of the drift velocity. Current is rate of flow of charge. So as it is the rate of flow of charge, and if you write its expression, then we can write current I as delta Q by delta T. Delta Q will be the small amount of charge that will flow in time delta T. This expression we use for constant current. If the current is constant to a circuit, then we can use this formula to find electric current there. Or this can also be used for average current. Okay. So we can use this one for constant current or average current. But if suppose the current is not constant, it is a variable. So in that case, we use expression I as dq by dt. This is for variable current, and in fact this is the expression for instantaneous current. Okay, like this was the expression for the average current, and this is the expression for instantaneous current, because if the current is a variable quantity, then it will have different value at different instant of time. So that is why we take their instantaneous current, and which is represented as dq by dt. Now you know that unit of electric current, this is ampere, that is the SI unit, ampere. So this is for electric current. Now let's take some features of the electric current. Electric current is a scalar quantity. Okay. Now suppose we take one circuit. This is suppose a cell connected to a resistor. Suppose this is of 6 volt, this is 3 ohm. These are the points A and B. If you have to find the value of the electric current in the circuit, you can directly find I as V by R, so it is 6 by 3, that is 2 ampere. If it is asked what is the direction of the current, then we say that it is from A to B, because the conventional direction of the electric current in the circuit is from the positive terminal to negative terminal of the source or the battery or cell through external circuit. So here it is from A to B. If you change the polarity, then it will be from B to A. So for this case, the direction is from A to B. Now the electric current here has magnitude, that is your 2 ampere. It has direction also. Then why we are taking it as a scalar quantity? Just because for a physical quantity to be taken as vectors, it is not necessary only to have magnitude and direction, but it should also obey the laws of vector addition. Electric current does not obey the laws of vector addition. That is why electric current is a scalar quantity. Okay. Like suppose you have the current flowing as say 3 ampere and 4 ampere, the current which will come out will be your 7 ampere. No matter whatever is the angle between these two branches through which the currents are flowing. But if it is a vector quantity, in that case the resultant will definitely depend upon the magnitude as well as the angle between the two. So this is a scalar quantity. Second point, electric current is due to flow of free electrons through a conductor, and it is due to the flow of free electrons and ions in case of electrolyte, and it is due to the flow of electrons and holes in case of semiconductor. So do remember that electric current is due to different particles which are taking part in constituting current in different cases. Only for the conductors, if you are taking, it will be due to the free electrons. Okay. Next point is the direction, conventional direction of current. Conventional direction of the current is in the direction in which a positive charge will move. That is also, it is in opposite direction to flow of electrons in the circuit. Because we have taken the direction of the current as the direction in which positive charge will move. So here, suppose if I take any circuit and we have suppose a conductor connected with this one. So the direction of the current in this one is from left to right, whereas the free electrons which are there, they will be moving in this opposite direction. So they will be moving in this direction, whereas the current will be flowing from left to right. So it is in opposite direction there. Okay. So do remember this thing, that the direction of electric current is in the direction in which positive charge will move. For conductors, if you are taking, it is in the direction which is opposite to the direction of flow of electrons. Because you will get many cases there, like in semiconductors, the electrons and holes are moving in opposite direction. The charge possessed by the electron and that of the hole in magnitude, both it is same. But nature-wise it is opposite. So they will be definitely moving in opposite direction. But if you take the electric current in the circuit, it will be due to the combined current. Like you have suppose a semiconductor in which suppose the electrons are there, which are moving say left to right, holes will be moving or their direction will be taken in opposite direction to that. So if I take electric current due to electrons as IE and electric current due to holes as IH, then the total current will be IE plus IH. It is not difference. Just because if suppose the holes are moving in this direction, the current due to hole is from right to left. Electrons are moving from left to right, but the current constituted by electron will be in opposite direction to the direction of flow of electron. So IE will also be in the same direction. So the total current will be IE plus IH. Next point, conventional direction of current is from positive terminal to negative terminal of the source or the cell or the battery, whatever you call, through external circuit. Like if you have a cell here, then the direction of the current will be from positive to negative through external circuit. This is the external circuit. So this will be the direction of the current, positive to negative terminal through external, not through the cell. Okay. So these are some of the important features of the electric current that you should know. Let's take few questions. Then the basic concept of the electric current and its use will be more clear. So the first question which we are taking, the amount of charge flowing in time t through a cross section of a wire is given as Q equals to 5t square plus 3t plus 1, where Q and t are in SI units. Find the value of current at t equals to 5 seconds, and second, find average current flowing in the duration 2 to 5 seconds. So let's take, it is given Q is 5t square plus 3t plus 1. We have to find current at t equals to 5 seconds. So that means here we have to find instantaneous current, because you can see that the charge is depending upon the time, and here from this we can get the value of current, which will be your dq by dt. So it is the differential of this quantity 5t square plus 3t plus 1, and that will give you 10t plus 3. So I is equals to 10t plus 3. If you want current value at t equals to 5 seconds, so I at t equals to 5 seconds, it will be simply given by (10 into 5 plus 3). We'll be putting value of t, that is 5, in this expression, and this will be 53 d. So this is the first part. Now second part, it is the average current in the duration t equals to 2 to t equals to 5 seconds. So I average, this was given as delta q by delta t. So as it is delta q by delta t, we'll take the charge at 5 seconds minus charge at 2 seconds and divide it by the time 5 minus 2. So if you put the value of t as 5 and then t equals to 2, so what you will get here? It will be 5 into 5 square plus 3 into 5 plus 1. This is the value of the charge at t equals to 5 seconds. Then it is your 5 into 2 square plus 3 into 2 plus 1. This is the value for charge at t equals to 2 seconds. This one. And this divided by 3, 5 minus 2. So this is your 25 to 5, that is 125 plus 15 plus 1. And this is your 20 plus 6 plus 1. That's divided by 3. 38. So here we have basically used the formula for the current, that is I equals to dq by dt if it is the instantaneous current which is asked, or I equals to delta q by delta t if it is the average current which has been asked. The current through a wire depends on time, as I equals to 10 plus 4t. Find the charge crossed through a section of wire in 10 seconds. Current is given as 10 plus 4t. We have to find the charge that has flown through the given cross-sectional area of the conductor in 10 seconds. So we know that I is dq by dt. So dq will be your I dt. If you want to find the total charge, then we'll have to integrate this. So the total charge will be integral of this quantity and will be integral from 0 to 10 seconds. So it is your, for I, if we substitute 10 plus 4t dt and 0 to 10. So this is your 10 into t plus 4t square by 2, 0 to 10, and this is also 0 to 10. So this is your 10 into 10 minus 0. This is a 2 and it is now 10 square minus 0. We have basically cut this 2 in the denominator from this 4. So it is 2 here. So now it is your 100 and this is your 200. So this will be 300 coulomb. So what we have done, we have used only 2 formulas here for current. One for average current and other for instantaneous current. And using this formula, you can get either the current which is required in the particular problem, or the charge which has flown through a particular section of the conductor. So we can use these formula. Current in terms of drift velocity. First of all, just try to understand what do you mean by drift velocity. Suppose we have a conductor. In that, we'll have the free electrons. Even if you do not apply any potential difference under, then the free electrons of that conductor, they will be in motion due to the thermal energy which they have possessed. So they will be in the motion, but their motion will be a random motion. As a result, the net current due to them will be 0. So their random motion will not contribute for any electric current through the conductor. But whenever we apply a potential difference across the conductor, that means we are setting up an electric field, then again the free electrons, they will be in motion, they will be colliding with the other electrons or the ionic core, but still after every collision, they will be directed in a particular direction given by electric field. They will experience force due to that, so they will be moving in that specific direction. So the net rate of this change of displacement per unit time by the free electrons or the charge carriers when an electric field is applied, that is your drift velocity. Okay? So we'll try to find expression for electric current in terms of this drift velocity. Let's take, we have a conductor. That conductor, suppose I is the current which is flowing. It has many free electrons. They are in motion. Suppose small n is number of free electrons per unit volume. If you take it conductor, otherwise if you take in general case, it will be the free charge carriers. So in that case, it will be the number of free charge carriers per unit volume. Let's take an elementary section of this conductor having cross-sectional area A and having thickness delta H. So we have taken this one. Now the volume of elementary section, this will be your A delta X. Now if we try to find out how many free electrons are there in this elementary section, in that case, number of free electrons in elementary section, that will be your A delta X into N. Now the charge possessed by the free electrons present in this elementary section. So if I assume that E is the charge on the free electrons there, so the charge possessed by free electrons in elementary section, that will be simply A delta X into N into E. If I take E as the magnitude of the charge possessed by the free electrons. Okay. Therefore, electric, and suppose delta T is the time in which the charge carriers pass through this elementary section. All the charge carriers which are there in this elementary section, they will pass through it in time delta T. Therefore, rate of flow of charge, this will be your A delta X N into E divided by delta T. And this rate of flow of charge is nothing but your electric current. So this will be equals to NEA delta X by delta T. This delta X by delta T is the drift velocity. So we write this one as NEA VT. This is the expression for electric current in terms of drift velocity. Okay. So this is the expression for electric current in terms of drift velocity. Another term which we do, that is the electric current density. Electric current density will be electric current flowing per unit area of cross section. So this electric current density, if I represent by J, this will be electric current per unit area of cross section. Now the expression for electric current we have just derived. This is your NEAVD. So this term now for J will be equals to NEVD. So this is the expression for electric current density, which is the electric current per unit area of cross section. And if you take the unit of electric current density, as it is the current per unit area, so it will be ampere per meter square. And do remember one more thing, electric current is a scalar quantity, but electric current density is a vector quantity. So electric current density is a vector quantity. You'll also find that electric current we can write as dot product of electric current density and vector area. Electric current is scalar product of electric current density and vector area. That is why you can also say that electric current should be a scalar quantity.